Welcome everyone to the Meta Platforms UCSB Emerging Technology Review. This is the second day of workshops, and this workshop is focused on data center efficiency. Yesterday's workshop was focused on smart buildings and improving energy efficiency in the post-COVID era. I want to first introduce Tressa Pollock, who's here. She's the interim dean at UCSB, and she's world renowned for structural alloy investigations, and glad to have her. So Tressa.
Okay, thank you very much, John, and welcome to UCSB, everyone. I'm very sorry that you're not here to experience that new building you see behind John, which is certainly award-winning and energy efficient. And that's certainly relevant to the topics that we'll be talking about today. Energy efficiency in data centers is obviously a really important problem, and we're really happy to see so many industry leaders in this area in attendance. And I especially like to acknowledge Catherine and the Meta team for their collaboration and support of research in this area. I think probably, Catherine, you've learned at UCSB, we really highly value our collaborative environment. And we know that teaming with industry allows us to work on relevant problems. And it also gives you access to our very talented students. And so it's a great thing for both of us. And to me, today looks like a really exciting agenda: AI in the morning, optics in the afternoon. I won't be able to stay for the whole time, but maybe we'll be able to get the overviews. And so I hope that you have a great workshop, that everyone generates a lot of new ideas and programs. And I look forward to seeing everyone on campus sometime soon. So thanks and enjoy, John.
Great, thanks, Tressa. Well, you can see Catherine Schmidtke here. I'll go to some slides and we can talk about the workshop goals. And I also want to highlight in particular Rob Stone and Bharath Muthia, who will run the two sessions in the morning and the afternoon. So thank you for all your organization. Catherine, you want to say a couple words, and I'll put up a slide on our goals.
Mute button. So yes, thank you very much, everyone, for joining. I'm looking forward to some great collaboration today. And so with that in mind, we thought it would be useful to put out some goals at the beginning to help us target that collaboration. So really the intention of today is to foster this collaboration, and we've targeted a few things that will help us increase energy efficiency in key areas of interest to hyperscale data centers. And so we've listed the key areas here, some of the things that we would like to discuss during the meeting and afterwards, of course. Memory accessibility and latency trade-offs. Those trade-offs are something that we have to make, and it's not an easy trade-off. So that's an important area. Identify the bandwidth and picojoule per bit requirements for each space, and that's because there's a number of different places that we use high bandwidth interconnects in the data center interconnect, in the network inside the data center, the compute interface, and that's a new and growing area, and then memory interfaces, which gets back to some of the trade-offs with latency that I was talking about. Not forgetting storage, and just that there's an opportunity to go and use photonics inside the chips in internal chip buses. And then another aspect we'd like to collaborate on is providing the context for solving energy versus data transfer in a whole system. So not just the photonics, not just solving energy efficiency for a small part, but doing it for the whole thing. And part of that is co-design between hardware and software. And you'll see that theme come, particularly in the morning session, because that interplay between hardware and software is very apparent there. So again, some of the points to focus on in that co-design are latency and error correction, cost, redundancy versus reliability, scale, and design for manufacturing. So hopefully we'll have an opportunity to talk about all of these points as we go through the day today. Thank you, John.
Great. Thank you, Catherine. So here's the schedule for today. So Catherine will first sort of outline the problems we face, the rapid growth of energy consumption in data centers, and obviously AI and machine learning in particular causing very rapid growth. And then in the morning, Bharath will lead a session on AI and ML optimization. And I want to thank all the contributors here, not just Meta Systems, but NVIDIA and Google, AMD, Broadcom, and UCSB. So that should be a very exciting morning. We'll take a short break, 30 minutes for lunch. And then in the afternoon, we'll move on to optical interconnects. And Rob Stone has organized this session. And again, I want to thank Microsoft and Broadcom, Intel, and Parallax, and as well as Meta and UCSB. So it's a very tight schedule, and but I think a lot of material, and we have several hours of discussion, one at the end of each of these sessions. And so again, if you're an attendee, you can type questions in on the chat button, and the moderator will read those. And if you're a panelist, then you can go ahead and just raise your hand or speak. So we're hoping to make this interactive. We're hoping there's time after each presentation to ask questions, and then have a more in-depth discussion at the end of each of the two sessions. So that's the plan. I think everyone knows Facebook or Metasys platforms. We all use it. I'd like to just briefly give sort of an overview of the Institute for Energy Efficiency, because probably many of the people here are not so familiar with it. And you can see in the video Mark Abel, who's the associate director. I want to thank him for all his organization of the Institute for Energy Efficiency. So the problem we all know about, that we have an energy crisis, we have a surplus of carbon and temperature rising, and one solution is obviously generating more energy and generating clean energy, but that is not our focus. Our focus is on reducing demand on energy efficiency, and doing so without retarding development, and then meeting that demand with alternatives. So we work very closely with a number of companies that do wind and solar, but our focus is really energy efficiency, and our focus is basically avoiding building more power plants, so becoming more efficient. This plot from Paternak is classic, but it just shows the evolution that countries go through. As they have higher standard of living, they typically use a lot more electricity. And the big issue here, of course, is the large fraction of the world, India, China, and others that are lower in the level of development. And as they move up, if they follow our curve, then we're in trouble. So the focus of the Institute is very much towards changing that curve. And what's shown here is very achievable. And there's a number of plans. We have our own plan for how to achieve this. But basically primarily focused on energy efficiency. So we formed about 12 years ago. The Institute is about 40 faculty and about 180 grad students, and encompasses 12 research centers, and has about 40 million a year in research funding. This is the way we historically were organized, and I show this because until last year, this was organization, and I really want to thank Steve Denbars and the whole LED lighting group for their real leadership. Obviously, we've gone from inefficient incandescent light bulbs to very efficient LEDs and now lasers. And the focus of the Institute is probably more on lasers, things like headlamps and lighting, street lighting, things like this, where you get really high power emission and very high efficiency. We had a group on electronics and photonics. You'll hear a lot about that in the afternoon today. A group on computing, again, you'll hear about that today, and Rich has done a great job organizing that. The workshop yesterday was on buildings and design that Igor ran. And again, that's a big energy consumption in our world. And they really focused on the directions to get zero net energy building systems. We have some effort on production and particularly storage. A number of new faculty have been hired in the storage area, and we're funding a bunch of research there out of the Institute. And the last one, of course, is economics and policy. You know, to what extent can we use Washington and the other governments to affect change? And obviously things like banning incandescent light bulb, you know, is one good way to accelerate LED adoption throughout the world. This slide shows how we're organized today. So one of the thrusts is on smart societal infrastructure. And so again, that is a bunch of things: smart buildings, smart grids, and so forth. And Manoush and Igor ran that workshop yesterday. And indeed, the challenge here is, you know, getting 50% renewable energy in just 8 years and 100% by 2050. And you see the other challenges here. One that today's workshop is more focused on is the center thrust. And Rich Wolski and Tim Sherwood, who are here, lead that with me. And again, we want to get, you know, more than an order of magnitude improvement in data center energy efficiency. And so that's what today is all about. In general, getting, you know, much greener AI. And again, that's the morning focus. And there's a lot of focus on quantum communications, quantum computing, quantum processing, and getting a large improvement. And so there's 3 labs, Galen Moody, Dan Blumenthal, and myself in Henley Hall focused on this. And so that's a very exciting area. The last one, which we won't talk about much today, is this Food-Energy-Water Nexus, led by Chandra Kritz and Steve Denbars and Bob Wilkinson. And again, as I think you're aware, things like, you know, indoor controlled growth of food, you can use 10% or less of the water that's being used today. And so in drought-starved areas like California, that's pretty important. And then underlying all of this is sort of the fundamental, you know, electronics, photonics, materials in particular focus, and UCSB is very strong in materials, as well as AI, machine learning, and William Wang leads that. We'll hear, he'll be present as well. And then again, policy and assessment. And these are pictures of all of them, and hopefully there's a bunch of them you'll see today. So as Tressa mentioned, and as my background shows, we completed a new building for the Institute for Energy Efficiency during COVID. And the background is the north side, which is primarily glass, and the south side has this umbra over it because most of the building is not air conditioned, and so it's very energy efficient, but solar heating is an issue. You can see some of the labs are on the outside here, but it basically the building is occupied and heavily used. The energy consumption of Henley Hall is about 40% less than a comparable lab building. And there's a lot of things we did from the very beginning to build energy efficiency into that building. And as a result, we've been recognized with LEED Platinum, which we're very happy about. And then actually 5 other awards that have happened since then. So again, the building's only been open for a year, but it's getting a lot of notice for its very efficient design. So we're very excited about that, and very grateful to Jeff Henley for donating the original donation that got it started. Here's an example of what we're talking about in terms of building energy efficiency into here. A little over half the building is not air conditioned, but it's naturally ventilated and largely naturally lit. And the labs have air conditioning in them for control of experiments. But there's this whole center area here. Hopefully you can see my mouse. It's not very bright, but this is basically a large chimney, and there's windows around the top that open automatically. So again, this is the focus of yesterday's session. But Igor has a lot of sensors throughout the building, literally thousands, and they sense temperature inside, outside, wind direction, and so forth. And again, all these windows open automatically. These windows open automatically, so as to promote airflow if it's too warm, and obviously if it's cold, then minimizing that. And so that's just one example, but there's literally a list of 100 things that were done to make this building more efficient. There's a number of groups that are located in Henley Hall, and particularly in super energy efficiency, but a bunch of other centers that exist there. I'll show a list in a second of a bunch of labs. In particular, one of the labs is focused on making more efficient data centers. And so it's designed to have a very heavy heat load, which was an issue for an energy efficient building, but very efficient cooling, water cooling, and things like this. And so we want to thank Meta Platforms for donating to name the lab and get the research started there. And a bunch of the research at UCSB you'll see is sponsored by Meta Platforms. So we're very grateful for that. And we're looking at other companies to get involved in this laboratory. Here's a list of the other labs as well. As I mentioned, there's 3 quantum computing labs, there's AI labs, computer architecture labs, building efficiency labs, as well as material labs. IE has an industry partner program, and the partners are listed here. So we're very grateful for your donations and support of research here and just interactions in research. And we're certainly looking to expand that. And that's one of the goals of this workshop. We have a seminar series. So again, if you get on the mailing list, you'll get notices of these. And certainly these days, they're all hybrid, virtual, as well as in person using the auditorium in that building. And we sponsor a lot of research grants. And those will actually probably roughly double this year. We've got new funding to fund these seed grants. And the idea is to start new programs that are relatively simple to do. A short application and short time for approval. And then you can follow up with longer term funding. So with that, I'll return to the schedule that we have. And if there's any brief questions on the building or the institute, I'm glad to take those. I can't see the chat here, so maybe Mark, you can read them if there are. But otherwise, we'll move on, and Catherine will introduce the problem that we're solving today. So again, the morning session is on AI/ML, and Bharath will lead that. The afternoon session is on optical interconnects, and Rob Stone will lead that.